G'day everyone. Bit of a quicker video today, but we're just going to have a look at how to solve some log equations. Um, and these are can be a little bit tricky, but they follow a lot of the same sort of principles that we've had before with solving equations. So in some sense, in some ways, that they're not too bad. But just remember sort of all your log laws and different things as sort of going in. All right, so let's have a look at some. Sorry, just before we start, that's a terrible A down there, but log base AX, the only time it's defined, if you think about this, the X must be greater than zero. It can't be equal to zero, definitely not. And it can't be negative because you can't raise something to a negative power. Um, sorry, you can't get a negative number if you raise a number to a power. It just doesn't happen. So it's only defined when X is greater than zero. And also that the A must be in positive real values, and it can't be equal to one. If it was equal to one, you just get a straight line. Like you're not gonna actually get the proper function. Nothing happens. And so that's a sort of where that log base A function is defined. Okay, so let's have a look at a couple of examples. Just keep that one in mind because so X must be positive. Whenever you've got a log, if you get an answer to a solution to an equation and you get a negative X value or a zero X value, then discount that value. It cannot be part of your solution. So that's just a reminder. Okay, so let's have a look at some examples. Okay, so firstly, let's solve this equation here. So we've got log base 4 of X is equal to 3. Um, really simple one. I'm just going to rewrite this a little bit. So remember that means 4 to the power of 3 is equal to X. Okay, because remember 4 is the base, 3 is the power, and X is the answer, or the numeral, the equivalent value. And so therefore 4 to the power 3, 4 times 4 is 16, 16 times 4 is 64. So X is equal to 64. Nice and easy, that one. Yeah, that's way below us. Let's get on to something a bit more interesting. Let's have a look at this next one. So if we've got log base 2 there, got a log base 2 over here, but then we've got this screwy little number here. And what can we actually do about this number? So there's a couple of things you can do, but it's always going to be really awkward with this 3 sitting there because we can't actually put it together with any of the logs. We could maybe move that log base 2 over to this side and do a subtraction and maybe bring the 3 over to this side. And then you're going to have sort of this horrible sort of thing, but it's actually not going to sort of simplify out very much. And so here's just one of the first little tricks that you might see around the cup. So what we can do is, I'm going to leave that as log base 2 of X minus 1. What I'm going to do is just rewrite this 3. Can we write it with a log? And yeah, we can. So I'm going to go 3 log base 2 of 2. And why did I do that? I'll just rewrite the rest and then explain it so you can see that that's the only thing I've changed in here. Okay. Why did I do that? Because log base 2 is equal to 1. And so 3 times that is equal to 3. And so I haven't changed the value of anything. All I've done is done a log of its own base. And so that's just equal to 1. Now that I've got that, I can put things together. Okay. So, well, actually, there's one more step I need to do before I can put it together. Okay. So let's go do that a little bit more work. So that's X minus 1. Now, I can write this as log base 2 of 2 to the power 3. I can put that 3 in there. And so that I can start putting things together. Because remember, like in the last video, that we can't put logs together if there's numbers out the front. Okay, it's not one of our log laws. We're not allowed to do that. So let's put the power on the inside. Sorry, that 3 on the inside as a power. Okay. All right. Now that we've got log 2 and log 2, I can put them together. And so just remember, when we're adding logs, then we multiply. Okay. So what this is going to be is that's going to be log, and it's going to be X minus 1, and that's log base 2 to the 3, so that's 8, so that's multiplied by 8. So I'll just put that there, multiplied by 8, is equal to log base 2. I'm going to run out of space here. See how we go. I reckon I can do it. So I've got that, and now that we've got log base 2 on both sides, I can equate everything that's on the inside. So if log base 2 of that must be equal to that. And so we can do some fancy footwork here, and then we can sort of say, well, therefore, and I'll just expand it out now because I know I'm going to need to expand it. So 8x take away 8 is equal to 2x plus 1. And all of a sudden, it's looking very good. We can sort of do a bit of answer here. So 8x take away 2x, so it'll be 6x on the left-hand side, and it'll be 1 plus 8 on the right-hand side, so that'll be 9. And if I simplify that down, so x is equal to 9 on 6, which is 3 on 2. So that's my answer. X is equal to 3 on 2 for that one. Hope that makes sense. You need to get the bases all the same so that you can deal with the numbers, and you can't have these little stinking you can't have a little 3 out the front. You got to do something with that before you start putting things together. Okay. All right. Let's have a look at this last one. And with this last one, this is a trick that we've you need a trick that we've done before, and you would have seen this type of thing. When you see me do it, you go, oh yeah, we've done this, we've played this game before. And that's how you get good at maths. You just sort of do different examples, and you go, I've got some tricks up my sleeve here. Okay, because now we've got a log base 2 of x. We've got, oh, thought I was on my highlighter. We've got this thing squared here this side, and then we've got the same thing log base 2 over here as 1, and then we've got this other number by itself. And to me, that screams out to me a quadratic, right? You got something squared, and then you just got, a something on this side, and then you got a number. So to me, that feels like a quadratic, and you should hopefully sort of starting to sort of recognize some of these things, okay? So what I'm going to do is I'm going to say let a be log 2x and start plugging it in. So therefore we've got a squared is equal to 7a plus 18. It feels nicer already, doesn't it? And let's bring it all on one side. A squared minus 7a minus 18 equals 0. Let's factorize that guy. So we're going to have a, gee, I'm getting older, my a's are starting to look like 9s. It's bad. 18, so 18 will be 9 and 2, so 9 and 2. Now I've just written a 9 and it looks like an A. 9 and 2, to make negative 7 I need negative 9 and positive 2. Okay, so therefore we have A is equal to 9 or negative 2. Now let's put our value back in there, so now we're going to sub back in, so therefore we have log 2x is equal to 9, or log 2 base x is equal to negative 2, and we just need to write the solutions out. Okay, so for this first one, log base 2x is equal to 9, so that means 2 to the power 9 is equal to x. Okay, 2 to the power of 9 is equal to x. That was very messy, my apologies. I don't even know what that is, 2 to the power 9. I'm just going to leave it like that because it's too big, whatever it is. Can I get it? No, I think 2 to the power 10 is like 1024. So is 2 to the power 9 512? That's my guess, but I'm not going to do it. And over here, or here, we've got 2 to the power negative 2. 2 to the power of negative 2. Okay, so 2 to the power of negative 2 is equal to x there, and I will equate that one. That one's 1/4. Okay, so there they are my two solutions for that equation. So I solved the quadratic, I substituted back in my a, and then I pulled out my solutions. Hope that makes sense. See you in the next video.